Good evening, everyone. Hello. Am I audible?
Yes, madam.
Yeah. Okay. How are you all? All good? Hello.
Yes, madam. Everything is fine. Thank you. How
Yeah,
are you?
everything is fine. I'm good. How was the day? Why, like, there are less number of people? What happened? What about the other people? They're not even speaking. They're not even unmuting themselves. Guys, speak up
They will come after some time, maybe.
after some time.
Yeah,
Okay.
yeah. I mean, maybe 5 to 10 minutes later.
Sorry.
I mean, maybe 5 to 10 minutes later.
5 to 10 minutes. Oh, okay. Okay. So let's let's start with the session then. Okay. Shall we start with the session?
Yes,
So,
ma'am.
ma'am, it's a week 4 summary session, I guess.
Yeah, it's an open session for the week 4.
Okay.
Have you just gone through the lecture of week 4?
No, ma'am, not yet.
Not yet? Okay.
Yes.
What about others?
Ma'am, am I audible?
Yeah, you're audible.
Yeah, I have gone through the week 4.
You have gone through week 4?
Yeah, I've already submitted the graded assignment as well of week 4.
Oh, nice. So how was week 4? Was it easy or tough? It's easy, right?
It's easy, but more calculation. Calculations as more.
More calculation. Yeah, I agree with it. Okay. What about others?
Yes,
Nobody
ma'am.
has seen the lectures.
More
Okay.
calculation based.
More calculation based. Okay. And how was week 2 and week 3? Everybody understood week 2 and week 3, right?
Yes.
Yes,
Yes,
ma'am.
ma'am.
I
Okay.
just have
How
problem in just coefficient correlated. Otherwise, everything is fine.
okay. How was week 2 and week 3 was taught by a different instructor. So how was she? Was she good?
Yes, ma'am.
Yeah,
The
she was good.
yes, ma'am.
Oh, okay, that's it. Okay then. So let's continue with week 4. Okay. So now in week 4, what? Okay. So before that, we had one thing which was like you guys know variables, right? Okay. So
Yes,
in
ma'am.
variables, we have two types of variables, correct? What are the two types of variable?
Categorical and
Categorical and numerical.
numerical.
Categorical and
And
numerical. Okay, so we have two types of variables, categorical and numerical variables. Categorical variables are the variables which are like qualitative in nature, and numerical are the variables which are quantitative in nature. Correct?
Yes, madam.
Yes. So I can just represent a variable with like x, or I can just represent it as y. So okay, so I'm considering two variables like x and y. Correct. So normally here we are considering, so in week 2 and week 3 we all learned about the graphs and mean median, correct? We all learned about that, yes or no?
Yes, madam.
Yeah. Okay,
Yes, ma'am.
so now here what we're going to learn is we have two variables x and y. So now we have to understand the association between these two variables. So how are we going to understand the association? So there are methods, right? So first of all we're going to see about the categorical variables. Okay, categorical in the sense my two of my variables are categorical. That means my x and y both are categorical. Okay, that means this is qualitative, this is also qualitative. Maybe gender, maybe income level or something. So they are categorical. How I'm gonna calculate the association between these two variables? That is my first thing. Okay. Now in categorical, the first thing that you have to remember is how to make a two-way contingency table. Yes. Okay. What is a two-way contingency table? In the sense, like if we have some information. Okay, what are the information? The first information is there are 44 females and there are 56 male. Okay, second information that they have given is the people who are owning a smartphone. Okay, owning a smartphone are like 76 students, and who are not owning a smartphone, they are like 24. So I'm just using abbreviations like OS, that means owning a smartphone, NOS, that means no, not owning a smartphone. Okay, then the third information that we have been given is that there are the females who are owning a smartphone, they are like 34. Okay, and similarly there are the males who are like owning a smartphone, it's like 42. Okay, this is the information that we have been given. Now I have to tabulate this information. Okay, I have to tabulate this information in the form of columns and rows. Okay, so how I'm going to do that? Okay, so the first thing is we have to okay, so here what we are trying to understand is the association between owning a smartphone and the gender. Okay, what is the relationship between these two parameters or the variables? Okay, so the first thing is we have one variable owning a smartphone. Okay, so we have two conditions here, whether he will own or he won't own. Correct? These are my two conditions. Then the second thing is the second variable is my gender. Okay, either she is female or male. These are the two things. So one of my variable will be in the like in the column, and one variable will be in the rows. Okay, one here and one here. Correct? Now the second point is we will just fill up the values here. So if you see here, in total, how many females were there? 44. That means for females in total, this is the total column. So this will be 44. Similarly, for the male, here it will be 56. Are you able to understand?
Yes,
Yes,
ma'am.
ma'am.
Yes or
Yes,
no?
ma'am.
Okay, fine. Now, similarly, here what all things are given? Owning a smartphone is 76. That means the total here is 76, and then not owning a smartphone is 24. Now, female who are owning a smartphone are 34. That means this is 34, and the males who are owning it's 42, right? So here it will be 10 and this will be 14. So this is my two-way contingency table. Is this fine? This is how you make a contingency table. So this is my first step. Is this thing clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. Similarly, I can also make a contingency table to learn the association between owning a smartphone and the income level. Okay. Similar way, we will just draw it in this way. So we have owning a smartphone, whether it's yes or no. Then we have the income level. Okay, in income level, this is also like a categorical variable. In that, in what sense? Like we can have low income level, we can have medium income level, and we can have high income level. Okay, the main point is, if you see here, this is following some order. So if it's an ordinal data, okay, so we have to make sure that it follows some order here, maybe low, medium, high, or high, medium, low. Is that clear?
Yes,
Yes,
ma'am.
ma'am.
Yeah. Okay, so here also we will be having some values here. Okay, this is like total. Okay, I'm not filling it up. Okay, so this is how you can make a first step is how to make a contingency table. This is the first step to study the association between two categorical variables. Okay, now comes the second part, which is the relative frequency. Okay, can you guys tell me the formula of relative frequency?
Frequency by number of
Yeah. Total.
observations.
Yeah,
Number of
frequency by the
observations.
total number of observation.
Observation.
So this is my the formula of relative frequency. Okay, now here I have this table, right? So if I have to calculate the proportion of total participants owning a smartphone. Okay, what is this total? This is like 100, right? So I have this value. So can you tell me the total, the proportion of total participants who are owning a smartphone?
76 upon
100.
So it will be what? It will be it will be 76
0.76.
divided by 100. That
0.7.
means 0.76. Similarly, who are not owning a smartphone, it will be 24 divided by 100, which is 0.24. If I just make a table here, so the tables are like owning a smartphone, no, yes, female and male. Okay, so this was like 10, 34, 14, 42, 24, and 76. This is the total. Here we have total. Okay, this is my table. So this was like 44, this is 56 and 100. Okay, so the proportion that owning a smartphone, it is 76 by 100. Similarly, not owning a smartphone is this. Similarly, if I have to see the proportion of female participants who are owning a smartphone, it will be
44. No, no.
44 by
44.
34 by 44,
34.
correct?
34 by
34 by 44.
34 by 44. Similarly, the females who are not owning a smartphone, it will be 10 by
10 by
24.
44.
10
Similarly,
by
for this thing, right? So if you see here, we are dividing a frequency with its total frequency, right? That means we are dividing the each cell frequency here with the total, with its row total. Yes or no? 44 is the row total, correct? 56 is the row total for the female, no, sorry, male. Yes or no?
Yes, ma'am.
Yeah. So this is my row relative frequency. Is this thing clear? If we are
Yes,
dividing
ma'am.
the cell, if we are dividing the cell with its row total, this is row relative frequency. Similarly, we have column relative frequency. What is the column relative frequency?
column frequency particular
10 upon 24, 14
So
upon.
let's so let's
if
suppose
you
if I had this column, okay, this no, yes, then we have female, male, 10, 14, 34, 42. We have the total as 44, 56. Here also the total at 24, 76 and 100. Now the column will be what? We are just dividing the each cell with its column total, right?
Total
So
count.
here it will be 10 by 24,
10
34 by 76, 44 by 100, 14 by 24, 42 by 76, and 56 by 100. Yes or no? So this is my column relative frequency. Is this thing clear?
Yes, ma'am.
yes
Sure. Yeah.
Yeah.
Okay. So now we got to know the second step was to calculate the row relative frequency or the column relative frequency. Now the third step that comes is, now if we have this relative frequencies, how to judge or to know about the association between the two variables. So there are two things that you have to remember. What are the two things? If my row relative frequency is, okay, I'm just denoting RRF as the row relative frequency, okay, is same for all rows, or you can say that if my column relative frequency is same for all columns, okay, then we say that there is no
no
association.
answer.
Okay, and the second point is, this is the first point. Second point is, if my row relative frequency is different for some rows, okay, or I can say if my column relative frequency is different for some columns, okay, then I say there is an association. Okay, let's take an example here. So here we calculated the row relative frequency, and here we calculated the column relative frequency. Okay, so I'm just making the table again. I'm just representing I have calculated the relative frequency in terms of percentages. Okay, so the first thing is we have I'm just going with the row relative frequency. Okay, just apply the same rule in the column relative frequency as well. Okay, female, male. Okay, so this percentage is basically like 77.27%. Then we have 22.73%. Here we have 25%, and this is 75%. The total also, here we have 24%. Then we have 76%, and this is the total. Just, oh, that's fine. Okay, so the main thing is that you have to remember, if you have to study the association, you will see the first of all you will see that the people who are owning a smartphone are like 24%, and here who are not owning a smartphone is 76%. Now in each row for each of the gender you will check the comparison. So if you see here, my comparison is 24% and 76%. For female it is I have written it wrong now. This will be 75%. This is 25%, 26%, and 76%.
24%.
24%. Okay. So if you what the thing that you have to see is you have to see the comparison here. You have to see the pattern. Okay. So if we see for each of the gender, okay, so here we see that it is 77% who are owning a smartphone and 22% or 23% who are not owning a smartphone. Similarly for the males, 75% are owning a smartphone and 25% are not owning a smartphone. So if you compare, if you see the pattern here, it's the same. 76, 24, 75, 25, 77, 22. Correct? Yes or no? So I can say that my row relative frequencies are same for all the rows. Yes or no?
Yes, ma'am.
Yeah. Same in the sense they are following a same pattern. Is that clear?
They're approximate same.
Yeah, they're approximately same. They are following some pattern. They are following same pattern here. So the difference is like the pattern is like 76, 24, 75, 25, 77, 20. So they are like the same in the same range, you can say. Got my point?
For
Similarly, if I give you
example,
one more, sorry,
if assume like we have something like 60-40, so in that case we cannot say they are same, right?
they are not same. So I will give you just another example here. So this was the relationship between owning a smartphone and a gender. So if I see here, we say that there is no association. Yes or no?
Yes,
Correct? Okay.
yes.
Now I'll give you one another example. So I am here associating between, I'm understanding the association between the owning a smartphone and the income level. Okay. So this is high, this is medium, and this is low. Okay, so I've calculated the percentage. This is 10%, 40.91%, 64.29%. The total is 38%. This is 90%, 59.09%. Okay, here also we have the total. We are not calculated it yet.
Ma'am, when the proportion is asked, then we don't have to put it in percent value, right?
Sorry?
If we have been asked to give the proportion of RRF or CRF, then we don't have to make it in percent, right?
No. They're not asked you in percentages now.
Right.
Okay. So now if you see here, the owning a smartphone, it's like 38%, and who are owning a smartphone is 62. Like the difference between, like the pattern is 38% and 62%. Correct? In each, now we will check for each row, each income level. For high income level, who are not owning a smartphone is 10%, and who are owning a smartphone is 90%. But the pattern, what was the pattern? The pattern is 38% and 62%. There is a big difference. Similarly, for the medium, it is 40 point, that means you can say 41%, and this is like 59%. Similarly for the low, 64% and 36%. So there is a huge difference between the pattern. There is a huge difference in the pattern. Yes or no?
Yes, ma'am.
So I can say that my rows, the row relative frequency are not same for some of the rows. Yes or no?
Yes, ma'am.
Then I can say that there is an association between what? My owning a smartphone and the income level. Is this thing clear?
Yes, ma'am.
Yes? This is how you identify the association through the contingency table. Same goes for the column relative frequency. Okay, you have to say apply the same knowledge in the column relative frequency as well. Is this thing clear?
Madam, I have one doubt. Can I ask?
Yeah.
Suppose I mean to say we have a difference of the yes and no, assume 20%, but something is let's say 20-40 and something is like 60-80. So even though the absolute difference is 20, but
No, we don't have to look at the difference here. We have to look at the pattern here. See, the pattern that following is it should be 38% and 62%. The pattern it is following in the total, it should be same in each of the rows. You have to look at the pattern, not at the difference. What pattern they are following. So if it
okay,
was like in place of 10, it was like 39%, and this was like 61%. This was like this is like 39 or 38%, and this is like 61% or something kind of like that. In that pattern, if it had followed this pattern, then it would have been like same for the row relative frequencies are same for all the rows. Got the point? You have to look at the pattern, not at the difference. Is that
okay,
clear?
yeah.
Yeah.
I
Okay.
have doubt.
Yes.
Ma'am, if this type of questions came in our exam, then should we check the both row or column or just row?
No, just check only one, either row relative frequency or the column relative frequency.
Okay, ma'am. Okay.
Okay.
Okay, ma'am.
Okay. Okay. So the next part that comes is the last part is you can also study the association between the two variables graphically as well. Okay. How graphically? With the help of stack bar chart. You guys know what is a stack bar chart? Okay. Can you tell me what is a bar chart?
Yes, ma'am.
Tells us about
Sorry?
it's for the categorical data to tell the count
To
for the
tell the count of something.
frequency
It's
or
basically in this form, right? We have rectangular boxes, and these boxes,
same.
yeah. So this height actually represent the count. Yes or no?
Yes, ma'am.
Yeah.
Yes.
So this is my bar chart. Now, what is a stack bar chart? Stack bar in the sense that if I have bars, the two variables that I have is female and male. Now, the count of female is basically what? 44.
Hmm.
This is 44, and the count of male is basically 56. Correct? Now in this bar, I am just stacking the 2 points. 2 points in the sense I am I'm breaking down this bar into two parts, which is owning a smartphone and not owning a smartphone. Okay, so if you see here in this, 77% of the females are owning a smartphone. That means I can just represent that in 44 in this count, this percentage of people are owning a smartphone. Correct? And in male also, we can see 75% are owning a smartphone. So this is like here. Yes. So this blue part is representing actually owning a smartphone. Yes or no?
Yes, ma'am.
This is representing owning a smartphone. And the other part, which this is actually my not owning a smartphone. The rest of the part, which is like 22%
Divided
and
into
25%.
segments, right?
Yeah. So we have divided this bar into two segments. Okay. In this segments, we have owning a smartphone and not owning a smartphone. So this is my stack bar chart. In the bar, I am stacking two different things. Got the point? Two different categories, you can say. Is this fine?
Yes, ma'am.
Okay. So this is my stack bar chart. Then we have another chart. 100% bar chart. Do you guys remember what is a 100% stack bar chart? This is fail. This is female and this is male. In 100% stack bar chart, we are not considering the count. We are actually only considering the proportion. Okay, so we are not considering about the count. We are just considering the proportion or part to whole relationship. Then also in this, there is no count. Similarly, I'll just draw that this is 77%. This is 75%. Okay, so from here also you can see that there is no association, right? So that, like in both of the graph, if you see, there is no difference, right? It's like overall it's same. From the 100%, you are for sure that you can say that there is no association. Yes or no? Because there is no difference in the chart. Correct? Similarly, if I draw for the this is for the ownership bit and the gender. Okay, if I draw the graph for ownership and the income level, okay, how will I draw? So this
And the
will
second
be,
graph is a 100% stack bar chart.
sorry, second one.
The
Yeah,
second
this
graph,
is 100% stack bar chart. Okay,
yes, ma'am.
now if I so this is my high, medium, and low. So this is an ordinal data. So in if you are making a graph, you have to make sure that my order is fulfilled, correct, in the bar chart as well. Okay, now here I'm making 100% 100% stack bar chart only. Okay, similar to that. So this is for high, medium, and low. Okay, so if I make a graph here, so this is like the people who are not owning a smartphone. For the high level, it's like 10%, right? So this is, so like the rest of this, that's 90% who are owning a smartphone. Then we have 55%. Okay, sorry, this is, oh, 1 second. Okay, 90% who are owning a smartphone. Okay, then the medium level, which is like 55, whatever it is. So this is the part. And for the lower income, this was the percentage who are owning a smartphone. And the rest of them, this is basically not owning a smartphone. This segment is not owning a smartphone, and this segment is not owning a smartphone. So from here, if you see here, I see there is a difference in the graph. Yes or no? There is a difference here. It's a difference. This bar is different and this bar is different. There is no common. But if you see here, there was a common here, right? Like I can't see any difference between the two segments. Yes or no? So if I
Yes.
see there is a difference here, I can say that there is an association. Correct? Yes or no?
Yes, ma'am.
Yes.
Yeah. So so this is how you can like calculate the association between two categorical variables. So first point was, first we will make a two-way contingency table. Then we will calculate the relative frequency. We have two types of relative frequency: row relative and column relative. Then the condition is, if my row relative frequency is same for all rows or column relative frequency is same for all columns, we say there is no association. If they are different for some rows, we say there is an association. Okay, so this is, so first of all, you will see the pattern here. For each of the rows, you will see the pattern. If my pattern is same, I say there is no association. If my patterns are different, I say there is an association. Well, graphically also, I can just tell if there is an association or not, right? So if there is, if from 100% stack bar chart, if I see there is a difference in the graph, I say there, or like if I don't see any difference, I say there is no association. But if I see any difference, I say there is an association. This thing is clear?
Hello.
Is the things clear?
Hello.
Hello?
So, which basis of on the difference in row we consider association or not association?
Yeah. in difference in rows.
How much? Is there any limit or
What
on
limit?
the basis of pattern?
I couldn't get you. Say, speak. Hello?
It's
Are
the
you there?
pattern actually, not the actual difference. Madam, he's asking
Hmm.
like whether we have to see the absolute difference or the pattern. So it's a
We have to
pattern.
see the pattern, not the difference. I told you, we have to see
Yeah,
the
yeah.
pattern.
Okay, I got
Okay.
it.
Yeah.
Yeah.
Okay. Can we continue now?
Yeah.
Okay. Now the next part is this was all about. So in the previous we talked about the categorical variable. Now we're gonna talk about the numerical variable. That means my x and my y are both numerical variables. Okay, they are quantitative in nature. Now, when they are quantitative in nature, how I'm going to calculate the association between the two parts? The first thing is how graphically we can see whether how they are associated with each other. So graphically, we see through scatter plot. Do you guys know what is a scatter plot?
Yes, ma'am.
It is basically it is having two axes similar to bar chart, x and y axis. Okay, and
Explain
in
it.
the yeah, my
This
x axis is basically my explanatory variable. Okay, and my y axis is basically my response variable. Okay, so if let's suppose I have an example like age and height. Okay, so I have age and height like age 1, 2, 3, 4, and 5, and heights are like 75, 85, 94, 101, and then 108, something kind of like that. Okay, so I have this data. Now I have to represent this on a scatter plot. Okay, so I can just these are like my pair of values, right? 1 comma 75, 2 comma 85, 3 comma 94, then 4 comma 101, then 5 comma 108. So I am just representing these pair of values in a x and y axis. Okay, so my x axis is explanatory. Can you tell me which is the explanatory variable here?
age.
My age is an explanatory variable, correct? And my height is basically my response variable. Okay, can you tell me the difference? What do you mean by explanatory and the response variable? Anyone?
Yes, ma'am.
What do you mean by explanatory variable and the response variable? What is it? Guys, speak up. It's fine. Just speak it. Whatever it's like you have in your mind, just speak up.
Variable which
Something depend on the variable like age, height is variable
Hmm.
depending on the age.
Yeah.
As height age grows, the height grows. So
Hmm.
that might be the reason
I
that it's called the explanatory variable.
Yeah.
I think it is similar like cases.
Cases. Okay. Yeah.
explains
So. Hmm.
information about the variables.
Huh. So basically, what? Okay. So my response is my height here. My height is the response variable. And what explains this? The age explains my height. So that is the difference. Explanatory is like, like according, like, my age explains about my height. So if my age increases, my height also increases. Got the point?
It's dependable variable, right?
Huh. You can say that. Okay, so this is how. So this is like this is 1 point. This is 1 comma 75, 2 comma 85, 3 comma 94, 4 comma 101, and 5 comma 108. So this is how you draw a scatter plot here. Is this thing clear?
Yeah.
This is what a scatter plot is. Now I have the scatter plot. The second point is how to like study the scatter plot. So the first thing is how to describe the association through the with the help of the scatter plot. So there are four things that you have to remember. The first thing is the direction. Okay, direction in the sense we have two graph here. Okay, so one of my graph is like this. Okay, and the other graph is like this.
One is decreasing, one is increasing
Yeah.
with
So if you
respect to
see
the
here, yeah, I'm checking out the direction. First, my direction is upwards, and the second, my direction is downward. So we have two directions, up and down. Okay. So the first thing is to describe or to study the scatter plot is we will study the direction. In what direction my the scatter plot is going. If it's going upwards or if it's going downwards. Okay. Now the second point is curvature. Okay, curvature in the sense there are two things. Okay, same figure. I'm just so this is my one figure. Okay, and the other one is so if you see here, this is going straight,
Linear.
but this is going, this is having some curve. So we have two types of
polynomial
curvature.
That's
Sorry,
linear.
linear and
and polynomial
curve.
curves.
Okay, so we have to look whether the first thing is we have to look for the direction, whether it's going up and down. The second thing is if it's linear or it's having some curves. Okay, then the third thing is we will look for the variation. Okay, variation in the sense so we have one pattern like this. Okay, and the second pattern is so if you see here the difference between both of these graphs, here we have totally clustered values, correct?
Tightly.
Like all the datas are like closer to each other, but here we say there is a variation here because all the values are not closer to each other. They are like they're having some differences. They are like they are having some variations in that. Okay, so there is some variability there. And the third thing is we will check for the outliers. Okay, what are outliers which looks very different from the other data points. Okay, so if my scatter plot is like this and one point is here, one point is here, one point is here, and one point is here. So if you see here, my these points, this point, this point, this point, this point, they all are considered as outliers, which are acting as like they are like very different from the other data points. Okay, so these are the four things that you have to consider. Okay, this is how you can study a scatter plot. First, you will see the direction. Okay, what is the direction, whether it's going upwards or downwards. The second point is you will see the curvature, whether it's linear or curve. But here we what we are going to study is we are only going to study about the linear thing. Okay, then we will see about the variation, whether it's clustered, tightly clustered, all the data points are closer to each other. Then the second thing, if they are variable, then there is a variation. The data points are far away from each other. And then the fourth part is we will check for the outliers. Is this thing clear?
Yes.
Yeah.
Yes, ma'am.
So this is how you graphically you can just describe the association between two numerical variables. The second things that come is how numerically you can or you can say the quantify the association between the two variables. The first thing comes is the covariance. Okay, can you guys tell me the definition of covariance? It tells me the strength of linear association between
Two
Hey,
random,
guys,
two
speak up.
variables, two random variables.
Numerical variables.
Yeah. What happened today? Nobody is speaking something. Nobody is speaking anything. What happened?
Two variables.
Everybody is like low
Data
energy.
set, I think.
Everybody is in low energy, I guess. Yes. Okay. Okay, let's continue. So we have the covariance. Covariance is basically which tells me about the strength of the linear association between the two numerical variables. Okay, it is telling about the strength, like quantifying the amount of strength they have, the two variables have between them. Okay, so covariance is basically represented as covariance of between x comma y, which is actually summation of xi minus x bar yi minus y bar divided by. Okay, now if I'm talking about population covariance, then it will be divided by
N.
capital N. And if I'm talking about sample covariance, this will be summation of xi minus x bar yi minus y bar divided by
N minus 1.
Minus
n minus 1. Okay, let's take like how to calculate this. So let's suppose I have an x variable which is like 1 2 3 4 5, and I have y variable as 6 5 4 3 2. Okay, so the first thing is you will calculate the x bar and the y bar. Okay, so if you see here my x bar, so for the what is the mean of x bar?
3.
It will be 3.
Yeah.
Similarly, y bar will be
4.
it will be 4. Okay, so I've calculated. So now the second part is I will calculate xi minus x bar. That means I will be subtracting all the x values with its mean. So it will be 1 minus 3, which is minus 2, 2 minus 3, minus 1, 3 minus 3, 0, 4 minus 3, 1, and 2. Similarly, the second column, it will be yi minus y bar, which is 6 minus 4, 2,
2.
5 minus 4, 1, 0,
3.
minus
1.
1, minus 2. Okay, then the second part is I will multiply both of the columns here. Okay, so this will be what?
Minus 4.
Minus
Minus
4,
4,
minus 4,
minus
0,
1,
0.
0,
It's 1
minus
minus
1, minus 4.
minus 4.
Yeah, okay. So now the total is this is
Minus
minus 10.
10.
Okay, so now the thing is for population covariance, it will be minus 10 divided by what?
Is it 5 or 10?
5.
Yeah, it will be 5. So this will be minus 2. Similarly, if I have to calculate the sample covariance, it
Divided
will
by
be
4.
minus 10 divided by 4, which will be equal to minus 2.5. Okay, so this is my population covariance, which is minus 2, and this is my sample covariance, which is minus 2.5. Is this fine?
Yes.
Yes.
Okay, and the main thing is if my population covariance is positive, okay, if my covariance between x comma y is positive, then I say that if my x is increasing, my y will also increase. If my x is decreasing, my y will also. That means it will go in same direction. Okay, if my covariance between x comma y is negative, then they will go in opposite direction. That means if my x is increasing, my y is decreasing, or if my x is decreasing, my y will be increasing. That means it will go in opposite direction. Is this fine?
Yes, ma'am.
Correct? Okay. Now the third thing comes is correlation. Okay, can you guys tell me what is the definition of correlation?
XY
So,
minus X
friend
Y.
of linear
X
association
squared minus Y squared.
variables.
Yeah. So basically, this is also tells you about the linear association between the two variables. Okay, but this is more appropriate than the covariance actually.
Yes.
Okay.
Because it won't have units.
Yeah. So the why do we have correlation in covariance? If you see in the formula here, we have summation of xi. So in this, we have like for x variable, we can have different unit here. So let's suppose the unit is like u1, okay, u dash, and this unit is like y dash. Okay, so if I'm calculating the population covariance or something, it will be in u dash into y dash. So this is not at all appropriate. Like if I'm quantifying, if I'm telling you, if I'm telling you the strength of association between the two variables in this unit, it is not appropriate. Correct. So that's why we have the correlation. Okay. So what is the correlation? What is the it is known as Pearson correlation coefficient, which is represented by R, which is actually my covariance between x and y divided by the standard deviation of x into standard deviation of y. And the other formula is basically summation of xi minus x bar, yi minus y bar divided by under root of summation of xi minus x bar whole square into summation of yi minus y bar whole square. Is this thing clear?
Yes.
Yes,
Yes,
ma'am.
ma'am.
Clear.
Yes.
Yeah.
Okay. And the main important thing is what are the limits of the correlation coefficient? It is between -1 to
Minus 1
1.
to 1.
Okay. So if I say this is 0, this is 1, and this is -1. So let's suppose this is 0.75, 0.5, 0.25. Similarly, sorry, this is minus minus. 0.25, 0.5, 0.75. Okay, so I say that if my values are between 0.75 to 1 or minus 0.5 to minus 0. Sorry, minus 1 to minus 0.75, I say this there is a strong positive correlation, okay, or I can say strong negative correlation. Okay, in this here between 0.75 to 0.5, okay, we can say it's like a like average, or like you can say the moderate.
Moderate growth.
Okay, and then we have between here, this will be like, oh sorry, this will be like a weak association, and between this point it will be like no association. Okay, so if I'm saying my value is like 0.0, let's suppose it's like 0.8 or something, I say there is a strong positive correlation between the two variables. If I say it's like minus 0.8, I say there is a strong negative correlation. Is that thing clear?
Yes, ma'am. Ma'am, what is the difference between correlation and association?
Sorry.
Correlation and association.
A correlation and association, what? I couldn't get
I mean,
you.
can we
Hmm.
use the word correlation and association in this term interchangeably?
Correlation is a method to calculate or quantify the association between the two variables. So it's a method.
Okay.
Okay.
Excuse
Yes,
me,
ma'am.
ma'am.
Okay. Yes.
Ma'am, if I compute correlation coefficient using population covariance, then I can't take sample standard deviation in the denominator, right?
No.
Yes. If
If
I
you are
am using
taking,
population, then I have to use population standard deviation.
correct.
Okay, ma'am. Thank you.
Okay. But mostly what we take is we only take the population only for population covariance. Uh, Population or the sample. I guess we take only the population one only. Population covariance and divided by the population standard deviation of both of the variables. Like in general. Okay. But mostly we will be specifying it like if you just go through this formula, right? You don't have to calculate the population covariance separately, and like you don't have to like you won't be confused whether to calculate the population or the sample covariance or the sample standard deviation or something. Just go with this formula. Okay,
Okay.
this will make it more easier for you so that there is no confusions. Okay.
Okay. Okay.
Yeah.
Then, ma'am, it doesn't matter whether the question asked using population or using standard, sorry, sample. If I'm going through this formula, it will not
Hmm.
matter.
Yeah, exactly. So if you
Okay.
just go with the formula only, there will be no confusion as such.
Okay. Thank you, ma'am.
Yeah. Just I'm just telling to everyone, just go with the formula only. Okay. Don't confuse yourself whether I have to calculate. Like, let's suppose in the exam they are just telling you to calculate the correlation coefficient, but they have not specified whether you use the population or the sample something. You just calculate this in this format with the formula only, so that the answers are correct and there is no confusion as well. Fine.
Yes, ma'am.
Okay. So I'm not doing any example for this thing because we have already calculated the covariance. In the similar manner, we can just calculate the, so we have the covariance value. So for second thing is you have to calculate the standard deviation, or you can just go with this formula and you can calculate the value. Do I have to go with the example or is it fine?
No, no, it's fine.
Yeah, it's fine, right? Okay.
Ma'am, please give example. I'm having problem in this.
Okay. I'll just give you the example. So
Then I have one doubt.
yeah.
Like when you say r is equal to -1, so the way we see earlier, like if both x are, let's say, going, if x is going up, y will also go up in this case of, let's say, positive coefficient.
Hmm.
But like, what is the significance of r is equal to -1 here? It also is the same way, like if one goes up, the other will go down.
So, yeah, it's a negative, it's negative, right? So if my a negative in the sense they are going in opposite direction. If my x is increasing, my y will be decreasing, like that.
Okay, yeah, thank you.
Okay, so now the thing is we have x variable and y variable. First we will be calculating xi minus x bar. So for that we need x bar. For this my x bar was 5 and my y bar was, sorry, my x bar was 3 and my y bar was 4. So now here we will be calculating xi minus x bar. So 1 minus 3 is minus 2 square is 4. Similarly, this value will be 1, 0, 1 and 4. Okay. Now the second is we will be calculating yi minus y bar whole square. Okay. This will be like 4, 1, 0, 1, 4. Okay. Now the next thing is we have to calculate multiplication of xi minus x bar, yi minus y bar. So we have already calculated this. Okay, this was -4, -1, 0, 1, sorry, -1 and -4, correct? So we
Yes,
have all these values. Now put the values here. So my R is basically summation of xi minus x bar. The sum of this, that is -10. We have -10 here, divided by under root of summation of xi minus x bar whole square. So this is basically 10 and this is also my 10. So this is like under root of 10 into under root of 10. So this will be minus 10 divided by 10, which is actually -1. So it is coming out to be R is equals to -1. So it is a negative correlation. That means, so if you see here, my X is increasing 1, 2, 3, 4, 5, but my Y is decreasing 6, 5, 4, 3, 2. So if my X is increasing and my Y will be decreasing. So they are going in opposite direction. Is that thing clear?
Yes, ma'am.
Yeah.
Yes.
Yes.
Okay.
Thank you. Thank you,
Okay.
ma'am.
Yes. So till here correlation, till correlation, everything is fine, correct?
yes.
Okay. Now, so we are actually calculating the linear association between the two variables, right? So if we are dealing with the linear association, then we can just represent the association with the through the help of equation of a line, correct? Yes or no?
Yes.
We are dealing with the linear association between the two variables. If we are dealing with the two linear association, that means we can also represent or summarize the association with the help of equation of a line as well. So this
Okay.
equation of a line is basically we are calculating the r square. Okay, so what is the r square? So first of all, we will be having, okay, so if we have equation of a line in the sense, Okay, this is not in your syllabus or something. I'm just telling you. Okay, this is my data. Okay, so this is my data. The first thing is I will be putting a best fit line. So this line will represent my data. So this line is the best fit line for this data.
Linear
Now,
regression, right?
yeah, linear regression. Okay, so this
And we
line
are
is
calculating
basically
using R2 score.
R2 score. So this is one line. This is the best fit line, you can say. Okay, now I have to see, like, I have to see whether this line is a good fit for the data or not. So for that, we calculate the R square. So first of all, we will have the equation for this line. So equation of a line is basically what? Y is equals to mx plus c, correct? Yeah, y is equals to mx plus c. So let's suppose I'm talking about, let's suppose my equation of a line is price equals to 30.5 into the size plus 36. Basically, we are just calculating the association between the size and the price of the homes. Okay, so here if we see, my prices are basically y variable, my m is actually my slope. Okay, y is price, m is slope. Okay, then x is size and c are my intercept. Okay, so if you see here, my m is basically what? 30.5. That means it is positive. That's why my slope is increasing here. Correct? Okay. Y is my price, X is my size, and C is my intercept value. Y is basically, this is my response variable. This is my explanatory variable. Now, for this thing, if I see here, my R square is basically coming out to be 0.647. So it's basically, it's not, we can say that, okay, okay, so this is R square. So my value of R square is 0.647. This R square can also be calculated with the help of correlation. If I square the value of correlation, okay, I'll get, so let's suppose my correlation was 0.804. If I square up this value, I will get 0.647. So I can say that if I square the value of correlation, I will get the uh, R square value. Okay. Is that fine? Okay. So now if I want to know the limits, we know that my R is basically between -1 to 1, correct? And my R square is what? What will be my R square? If my value of R is -1, the value of R square will be?
From
One.
0 to 1.
It will be 1 and it will be 0 to 1, correct? So my limit of R square is basically between 0 to 1. If it closer to 1, we can say it is the best fit line. If it is closer to 0, I say it's a not good fit. The line is not good fit for the data. Is it fine?
Yes.
So let's suppose if my R square is basically 0.02, this is not a good fit. If my R square is basically 0.08, 0.8 or something, okay, 0.08 or something, whatever it is. So it is a good fit line, you can say. Okay, so this is how, so this is like it's not that important. Okay, just for the knowledge, or you can say like few questions will be there from this topic. Okay, maybe MCQ type of questions, you won't have to you don't have to calculate any R square or something. Maybe it will be like conceptual based questions. Okay, is this fine?
Yes, ma'am.
Is R square clear?
Yes, ma'am.
Yes.
Yes,
Okay.
ma'am. Yes, ma'am.
Now, the last part comes is, let's suppose I talked about when my two variables are categorical, or my when two variables are numerical. If I say that my x is numerical, okay, and my y is categorical, in that condition, how will I calculate the association between these two variables? So here comes our point biserial
Correlation.
co biserial correlation coefficient. Okay, this is the thing. What is the formula? It is represented by R PB, which is x bar naught minus x bar 1 divided by the standard deviation of x into under root of p naught p1. Okay. X bar naught is basically, so let's take an example.
Amount.
Okay. So we are just studying. So we have an example. Okay. So we have people here, or you can say the students here. We have the scores here. Okay. And we have the groups here, whether they are pass or fail or something like that. Okay. So there are like A, B, C, D, E people. The scores are like 8, 6, 7, 4, and 5. The groups are like 1, they're pass, they're fail, they are fail. Okay. Now, so if you see here, what will be my x here? If my x is a numerical variable, what will be my x? It will be the test score, correct? And my groups, whether they are pass or fail, it is basically my y variable. Fine.
Yes, ma'am.
Okay.
Yes.
Okay. Now, the first point is in the formula is it is x bar naught minus x bar 1. That means we are x bar naught is considering the average who have failed. Okay, I am just considering that my 0 is representing the fail and my 1 is considered as the people who are pass. Okay, so x bar naught in the sense the average who have failed, the average students who have failed. So x bar naught is basically what will be the values? It will be what will it be?
The first value is 8, ma'am.
This is 8, yeah.
And we are considering the failed
So
Seven,
it will
madam.
be 4
Seven.
plus 5
the 4 plus 5.
divided by 2, which will be 4.5. Similarly, what will be my x bar 1? That means the average who have pass the exam. Okay, so the average will be what? It will be 8 plus 6 plus
8.
7 divided by 3, which will be equal to 7. Correct?
Yes, ma'am.
Okay. Now, the second thing is you have to calculate the standard deviation of x. Standard deviation of x in the sense you have to calculate the standard deviation of this part. That too you have to calculate with the formula. Okay, so let's suppose the value is like 1.414. Okay, now the second thing that comes here in this p naught and p1. Okay, p naught is basically my proportion of students who have failed the exam. Okay, so this will be how many of students have failed the exam. If you see here, out of
2
5
on
there
5,
are
ma'am.
2. So it will be 2 by 5. Okay, p1 will be the proportion of students
For pass.
who have passed. Okay, so that will be what? 3 by 5. Okay, so we have all the values here. We have x bar naught. So this will be, so RPB will be mod of x bar naught minus x bar 1 divided by standard deviation of x into under root of p naught into p1. So if you put the values here, so this will be 4.5 minus 7 divided by 1.414 into 2 by 5 into 3 by 5. So if you solve this, you will get some value like around 0.87. Okay, so this is how you calculate a point-biserial correlation coefficient. Is that thing clear?
Yes.
Yes, ma'am.
Yes.
Yeah. Okay. So
Yes.
So this is the whole thing that was there in week 4. So what are all we learned is the first thing is we learned about the correlation between the two categorical variables with the help of contingency table, relative frequency. If my relative frequencies are same, I say there is no association. If they are different, they are associated. With the help of stack bar chart also, we calculated we studied the association between the two variables. Then the second part is, if we have two numerical variables, okay, so first thing is, by graphically we can study the association. Okay, so with the help of scatter plot we are studying it. If my scatter plot, if we see the direction here, if my direction is going upward or downward, if it's linear or curve, if there is a variation, sorry, if there is a clustered or if there is a variation, we see the outlier as well. So this is how I can study the association. The second part is, if I want to quantify it, the association between the two variables, I will use the covariance. What is the covariance? It is the strength of the linear association. Okay, so we have two types of covariance, which is population and sample. Population is summation of xi minus x bar into yi minus y bar divided by n, capital N. If we are considering population, we divide it by the capital N. If we are considering sample, we will be dividing it by the n minus 1. So this is how you calculate my covariance. Okay. Now, if my covariance is positive, that means my x and y will be going in same direction. If it's negative, I say they are going in different direction. Now the second part comes is the correlation. Why we are calculating the correlation? Because the covariance, the units are not defined properly. That's why we have the other unit, which is the correlation. So if you see here in the correlation, my covariance, it is having some unit. Here it has some unit. Standard deviation also have some unit, and standard deviation of y is also having. They will get cancelled. So that means it will be a unitless quantity. So that's why correlation is more better than the covariance. So correlation is basically my covariance divided by the standard deviation of x into standard deviation of y. The limits of correlation is from -1 to 1. And we have this bar, like if it's between -1 to -0.75, or you can say 0.75 to 1, we can say it's a strong negative or strong positive. And other than that, we have moderate, we have weak, and no association as well. Okay. Now the second thing is, we have R square. That means if we are talking about the linear association, we can also summarize the association with the help of an equation of line. And if we have to see whether my equation of that line is best suited for the data, we calculate the R square. Okay. So R square, so the equation of a line is basically represented as y is equals to mx plus c, where y is my response variable, m is my slope, x is my explanatory, and c is my intercept. With the help of this, we calculate the R square value. Okay, my R square, the limits are from 0 to 1. If it's closer to 0, we say that it's not a good fit. If it's closer to 1, we say it's a good fit line. Okay, then the last part comes is, if I have one numerical and other is categorical, we use the point-biserial correlation coefficient to calculate the correlation between the two variables. Okay, that's it. That was all in week 4. Is this thing clear?
Yes.
Yes.
ma'am.
Yes, week 4 is clear to everyone. No confusions.
No.
Yeah. Okay, no doubts as well.
Hello, ma'am.
Yes.
Ma'am, can you explain point-biserial correlation coefficient once again, ma'am? Hello?
Point-biserial.
Yeah,
See,
ma'am.
so like in point-biserial is used when we have one variable is numerical and the other variable is categorical. We have two different types of variables in the same data. Okay, in a same table. So if you see here, I have one x variable is denoting the scores and y variable is denoting whether they are pass or fail. So if you see here, I'm just denoting pass and fail with some binary variables, correct? I'm just using 1, 0. It's like 1, 0. This 1 and 0 are not numerical. They're not quantifying anything. We are just representing my that whether the students have passed with one variable and if my students have failed with 0 variable. So this is like a categorical variable and x is representing a numerical variable. Now, if we have two different types of variable, I have to study the association between these two variables. So how will I study? I will use the point-biserial correlation coefficient. It is represented by RPB, which is mod of x bar naught minus x bar 1 divided by the standard deviation of x into the under root of p naught into p1. Okay, so x bar naught is basically, if I, let's suppose if my 0 is representing the fail, so that means x bar naught is the average of students who have failed. So I will calculate the average of the students who have failed the exam. So it will be what? So if you see here, my D and E, these two rows, like they are representing the students who have failed. So I'll just calculate the average of these scores, which will be 4 plus 5 divided by 2. Similarly, x bar 1 is representing the average who have passed the exam. So I will consider which all rows? A, B, and C. That means 8 plus 6 plus 7. Okay, so I will calculate the average here. So I got 7 here. Standard deviation is basically the standard deviation of this whole thing, this data, the x variable. Okay, then the second, third part is the P naught. P naught is basically the proportion of students who have failed the exam. Proportion in the sense, like from the total 5 students, how many of the students have failed the exam? So if you see here, this D and E people have failed the exam. So out of 5, 2 of the people have failed the exam. So the proportion P naught will be equal to 2 by 5. Similarly, P1 will be what? Proportion of students who have passed the exam. It will be, so 2, so out of 5, 2 were the people who have failed. So that means 3 of them have passed. That is 3 by 5. Just put the values here, you would get some values, which is 0.87. This is how you calculate the point biserial. Is this fine?
Yeah, ma'am, got it. Thank you.
Yes.
Got it? Yeah. Anything else?
Ma'am, where will you upload these notes?
Hmm?
The notes.
I'll, yeah, by today or by tomorrow morning, I'll just upload it.
Okay.
Okay? Yeah.
And ma'am, what is the relation between this
Ma'am,
correlation and the correlation matrix?
Sorry, once again.
Relationship between this correlation which we have and
Hmm.
the correlation matrix.
Correlation matrix. What is one? Correlation matrix?
Like when we are working with data and heat maps, ma'am, we get correlation
Hmm.
matrix, right?
Okay. Hmm. Yeah. So basically, if you see in that, so like the color detection, something kind of like that, no? Like they represent some colors and all.
Yes, ma'am.
Heat map or something, correct? You are talking
Yes,
about that.
ma'am. Yes.
So it goes with the same thing only. So if you see here, if you see that if one variable, like if it representing like one box is representing values like uh, mm, so, like these are like some boxes or something, some variables like let's suppose 1, 2, 3, 4. Similarly, 1, 2, 3, 4. So there will be like numbers. Like if it's like 1, so this is like 1. So same thing. So if I'm seeing here, it's like 1, 1. So the correlation between these two variables are like very high, like strong positive correlation. So like the numbers will be there on each of the boxes. So from that numbers, you have to study whether the correlation between the two variables is strong or low or something, like strength or direction of the relationship. That is like both are same. Here we are just using the box type correlation matrix type. There we are not calculating. So because see, in a data we have different types of variables, correct? We have different types of
Yes.
like data values, right? So we have to like know the association between each of the variables, right? Between two of the variables. If there are 5 columns here, so I have to check for each of the 5 columns. So one, I have to check one column with the other 4 columns. Similarly, the second, the other 4 columns, right? I have to check all of the association. So that's why we make a correlation matrix. A matrix, a box type, and we study the relation. Like the numbers will be there like 1 or it's like 0.8 or something. So 1, the correlation between 1 and the second variable is like 0.84. So it's like a very good association between the two variables, something kind of like that. So that's it. So it's the same thing, the correlation. Here we are just calculating between two variables, right? We have only two variables here, x and y. That's it. There we have a different, like tons of variables. Correct?
Yes. Okay.
That's it. Anything else? We won't be provided any calculator. The calculator which is there in the portal, na, that is only you can use.
So, ma'am, maybe you could give us some idea on how the exam will be. What are the main questions that will be touched upon.
But the scientific calculator will be provided, right?
No, no calculators are allowed. So the calculators
Ma'am,
that are
we
there,
will not bring them, but in the exam it is
in the
in
exam,
the
like
on the
online
screen.
calculator on the screen, on the screen, the scientific calculator, I guess. Scientific, like you can calculate the exponential and all, you can log and exponential you can calculate.
So, ma'am, can you tell us, touch us on how the
Sorry.
exam structure would be, what topics are more likely to have a heavier weightage on this?
The question paper has been like from each of the week, like from uh like it's a 40 marks of questions, right? So 40 marks of paper. So like 20 marks will be from week 1 to 2, and from week 3 to 4 it would be like 20 marks of like that. So mostly in week 1, what is it there? It's like general in what you can say. It's like conceptual based, right?
I'm
Like
sorry,
there
you
is no
said 30
numerical.
marks from week 1 to 2 and 20 from week 3 and 4.
No, 20 from week 1 to 2 and 20 from week 3 to 4.
It's a 40 mark exam.
40 marks of question paper, no?
Okay.
Yeah. So like it has been divided equally.
Hmm.
So like that. So from week 3 and 4 are crucial because week 2, 3 and week 3 and 4 are crucial because you're calculating the mean, median. There is a concept as well as there is a numerical thing as well. Correct?
Yeah.
So week
Yeah.
3 and 4 is basically like more, you can say you need practice and all. Week 1 is you need to know the concept. That's it. Like you should know the difference between the scales of measurement and all. The main thing is the scale of measurement between interval and the ratio scale. But don't worry, we have not provided any statements or something which will be confusing to you to understand whether it's an interval or a ratio thing. So you
Of
don't have to
course.
worry about that. Okay, it will be
Yeah.
a very simple thing. So the
Hmm.
main thing is just go through the concept and all. Have practice with what is mean, what is median, what is mode, when to use it, how to use it, and all. And just okay. So today the mock quiz one has been released, right? Just do the question paper. Okay, you will get some ideas like what type of questions we ask. So
Yeah,
that
what
will be
about
quite.
from the last week and all correlation, this what you just taught by serial scatter plot?
Sorry.
From the last week per se, how are the questions from there, like scatter plot, Pearson, what you just taught, by serial
Yeah.
and all? How are
Yeah. So
questions from there?
the question will be simple. Like you have to calculate, like you will be given some data or something. You have to calculate the correlation or something, or
Mm-hmm.
some, yeah, on the basis of the formula only you will be given the questions. Not that difficult.
Okay.
Yeah, it's not that difficult. See,
When
week
is the
1 to 4
revision
is
session?
like, sorry.
Ma'am, more than difficult, I'm just
Revision
trying to
session
figure out
schedule.
how.
Yeah, revision session has been scheduled, right? From the next week. On 9th, we have the revision session for week 1 to 2. And on 11th, we have a revision session for week 3 to 4. And on Friday, we will just discuss the mock quiz that we have uploaded, right? Have you guys gone through the mock quiz one? The deadline is on Friday, next Friday. So you guys try to
Okay.
solve it. Okay.
Yeah.
Then after you solve it, we will just have a discussion on that paper. Okay. Hello.
Look, ma'am, I have a doubt, ma'am.
Sorry.
Ma'am, I have a doubt in something. Can I ask you a doubt? Ma'am?
Yeah. What's the doubt?
Actually, I got zero score in week 3 mathematics graded assignment, but when I saw my graded assignment, then I just have two
I guess
three
there is some
questions
issue
were
in the
wrong.
portal because yeah, in many subjects the same thing is happening. I guess in stats one many of the students are also getting the same
Yeah,
issue,
but I
correct?
think it's now updated, ma'am, because I
It's not
just checked
update.
my
It's
phone.
now updated.
I think so. Yes, I think so.
Just
Because
check it
mine
once
is
again.
updated. Mine is
Just check
definitely
it once
updated on the
again.
dashboard.
Then tomorrow I will just talk with the support team, like a backend team, like what's happening. Just see
How
to it.
many minimum days it take to update, ma'am, the scores, graded scores?
The graded score will be updated in 1 to 2 days. So like on Wednesday, we the due date was on Wednesday, right? So like they said by today only they updated the marks. But I guess there is some backend issue or some technical issues. That's why the scores are showing 0. Maybe they have done something like Lakshan said that it had been updated. But let me know if it has been updated or not. So tomorrow I'll just check with the support team or the backend team, like what's the issue.
Okay, ma'am. Thank you.
Anything else?
Ma'am,
Yes.
which correlation method we use when the problem comes to find the correlation between x and y?
Which?
Correlation method we use.
Correlation matter.
Yes, because I have a confusion between these two.
I couldn't get you. There is only one correlation formula, right? I
Okay.
couldn't get you.
Xi minus xy. This is one. This is the.
See, there is a covariance and correlation. Both are different. So,
Okay, ma'am.
yeah.
Okay, ma'am.
So if we are
So,
asking, see, we will be asking if you have to calculate the covariance or if you have to calculate the correlation. In covariance, we will be specifying whether you have to calculate the population one or the sample one.
okay,
Okay?
ma'am.
Will
Yeah.
be there in the question, right?
Yeah, it will be there in the question.
Ordinary.
Yeah.
Okay, thank you.
Okay. Anything else? Anyone? That's it. Shall we end the meet now? Yes or no?
Yes,
Yeah,
ma'am.
thank you so
Yeah.
much.
Excuse me, ma'am.
Thank you, ma'am. Yeah.
Okay. Thank you,
Excuse me,
everyone.
ma'am.
Yes.
Ma'am, I am having a doubt related to Pareto chart that it
Pareto
must
chart.
be in descending order only or it may be in ascending too.
It can be in any order. It should be like in ascending or descending. It doesn't matter. That the main
Yes,
thing
ma'am.
is it should follow an order. Like the
Yes,
frequency
ma'am. Like,
should be in order.
yes, means it must be in ascending and descending too, no?
Yeah, it can be in any direction.
Yes, ma'am. Thank you.
Okay. Okay then. See you guys on Sunday.
Thank you, ma'am.
Okay. Thank you everyone. Have a great night. Okay.
Thank you, ma'am.
Thank
You
you.
too.
Thank you everyone. Good night.
Thank you, ma'am.
Thank you,
Yeah.
ma'am.
Bye everyone.